Hello everyone, welcome back. Myself Pranjali Mishra and today we are going to solve the questions on the subject Theory of Computation. The question will be asked in our NSEM examination, so we are going to look those questions one by one. Let's get started with our question 1. So the question 1 says three parts. So the first part says given notation of representation, the following components of formal languages. An alphabet is represented as a sigma sign and a string as W, an empty string represented as a sign this. Length of the string will be represented as mode of the string, that is W mode. Prefix and suffix will be T, languages L, operators on a languages are union, intersection and a star. Now let's look at the B parts or the B question that has been asked to question number 1. Define FA, acceptance of string by FA. Now FA stands for finite automata. A finite automata is a 5 tuple, that is Q, sigma, rho, Q0 and F, where Q is the finite set state, that is Q1, Q0, Q1, Q2, Q3 and Q4. Sigma is the finite state of input alphabet, that is what we are providing an input alphabet, that is 0 and 1. Q0 is an input set. Rho is the set of transaction functions. F is the accepting state or final state. Now, acceptance of a string by a finite automata refers to whether the finite automaton, when given a specific input string, ends up in accepting state after processing the entire string according to its transaction rule. If the automaton reaches an accepting state, it is set to accept the string, otherwise it is rejected. The acceptance or rejection of a finite automata depends on whether the final state is of the designed accepting states. Now let's look at the C part. So the C part says give four difference between finite non-deterministic finite automata and deterministic finite automata. So the difference between deterministic finite automata and non-deterministic finite automata are: first, that configuration is not allowed. That configuration is allowed in NFA. Multiple choices are not available corresponding to an input in DFA, and in NFA multiple choices are available corresponding to an input. Now in DFA, move is not allowed and move is allowed. In DFA, designing and understanding is difficult, whereas in NFA, designing and understanding is easy. Now let's look at D part of question 1. So the D part states true or false. So the first statement says if L is the language accepted by NFA M, then L is also accepted by DFA. This statement is true. If the language L is accepted by NFA, then statement L is also accepted by NDFA, that is deterministic finite automata. So the statement is true. Now statement B says for every non-deterministic finite automata, there exists an equivalent deterministic finite automata that simulates the behavior of non-deterministic finite automata. This statement is also true. Now, in NFA to DFA conversion for n state, NFA, there exists at most 2n states in DFA. This statement is false because it's not n 2n states in DFA. Okay, thank you so much for watching. If you like this video, make sure you like and subscribe. Thank you.